Good evening, everyone, and thank you for joining Jnanavardhini's session. It's always good to learn and explore more together. Thank you very much for joining. Namit is the speaker for today's Jnanavardhini session. Namit Kothari is the founder and chief consultant at Triple Plus Solutions, taking care of the software and web technologies. He's based out of Raipur, Chhattisgarh, and he has a flair for problem solving in almost any vertical. He loves to learn, unlearn, and experiment. Coming from a completely technical background, he tries to apply technical concepts to solve life problems, especially for SMEs. As per him, data privacy and protection are fundamental to everyone in the network systems. Over to you, Namit. We are looking forward to this engaging session on how blockchain is used to introduce data privacy. Thank you, Namit. Over to you.
Thank you, ma'am, for the nice introduction. I will start right away. I hope everybody has gone through the video link I have shared earlier. That is a prerequisite to understand the coming presentation. I will start with some fundamental concepts in data privacy, consent, and some few penalties and PII related information in DISHA, and then move on to the blockchain concepts. And later on, one will merge all these concepts to arrive at the solution proposed, which is there in the video. Reena ma'am, you had requested a slight introduction of the blockchain, which is there. We will come to that when we start the blockchain concepts. Can we go to the next slides, please? So starting with DISHA. DISHA is basically Digital Information Security in Healthcare Act that was proposed in 2017 by Ministry of Health and Family Welfare. This is still not enacted. This is still in a draft state only. But what it proposes over other acts and other guidelines for data privacy in the healthcare area, it's kind of consolidating them. The primary report which is referred for any kind of healthcare related healthcare data security in healthcare is the APSHA report. This report is also a good one, and this is a better report in my view, because it contains more control over the data controllers, data subjects, and everybody, basically everybody, every entities in the entire ecosystem. As per this particular act, the name, the PIF fields defined in this particular act are the given ones are in the red: name, address, date of birth, telephone number, email address, physiological, mental health conditions, the sexual orientation, the medical records, and history. So these are related with the current use case of medical data storage. As per this act, the data is completely owned by the individual whose information is being captured. So as per that concept, any data processing will require the consent of the individual for maybe for processing, maybe for storage, any kind of action or processing. So the individual's consent is utmost important and at the top of the pyramid of the structure. The second point this particular act envisages is it allows direct data sharing between two hospitals. If you see the last lines, which are in green, it allows that, which is a very good thing, because currently what happens is in hospitals, the data is basically siloed. So if let's say you visit in a hospital for treatment, your entire data will be limited to that specific hospital's premises. It cannot be usually shared between hospitals for reference or any other kind of referrals or any other kind of treatment opinions as well, unless the patient gives explicit information. So they will have to have some explicit out of the way mechanism to share that data. This particular act allows that by default. So this is one of the major thing which allows us to arrive at the solution we are going to come at. So let's move to the next slide. This particular act also allows for breaches in data health information. So this particular section, if you come to the gist of it, it says if there is a serious breach of the either not providing the information, or if there is a failure to comply with the time specified or the directions issued by the authorities, or even if have been if there is no response from the the person who has breached the information. This particular act says that there is a minimum penalty of 1 lakh rupees, and that will continue, and per day penalty of 10,000 rupees to a maximum of 1 crore. So these are the boundaries under which this thing works. There's another penalty for theft, which is in the next slide. Let's go to there. It says, and there's an imprisonment if, let's say, there is a theft of the data of the individual from a hospital. This draft act suggests that there shall be an imprisonment term up to 3 to 5 years, or there could be a penalty of 5 lakh rupees, or both. So these are the constraints under which this draft is there. Obviously these are flexible limits, but for initial values, these are the limits. So if somebody intentionally does this, so the penalty would, if there is theft of the data, it's like 5 lakh rupees for that data. I mean, if I see it the other way around. So let's move to the next slide and let's see what enables us to arrive at this solution. PII is basically the fundamental driving entity for this solution. So we have understood that there is data privacy involved, consent is required at each stage, and there are penalties which we need to avoid to arrive at the solution. Now let's come up with what the blockchain concepts. I'll start with the centralized versus decentralized systems. I am sure you can see on the left hand side there's a central entity which everybody is connecting to. I will give an example for this, which is the current banking system is like that. If I have to say I have to transfer money from one person to the other, I'll have to transfer it from through a bank, a central entity. So if the bank fails, the entire transaction fails. Let's come to the decentralized part. The decentralized systems are those systems where each entity becomes a bank itself, and there are you can assume that the entity itself is the bank, and the transactions happen between the entities and the peers. So there is no central entity, and there's no single point of failure of the transactions. But this requires that whatever transactions are happening between, let's say, AB and CD, all of the transaction need to be there with the single entity as well, to ensure that the transaction integrity is maintained. So if a transaction happens between A and B, and another transaction happens between B and C, the transaction details of B and C can also be shared with A, to ensure that the transactions are equally shared between everybody, and that information of transaction is between B and C is there with A. I'll take the questions at last, but let me continue with the other concepts. Now, this concept enables us to arrive at a structure which is right below, which is the structure of a blockchain. Blockchains is nothing but a connected sequence of data blocks. When I say data blocks, it's a series of transactions between which are stored within the single blocks. So let's say I'll take the example which is being shown here, block 0. So I start with block 0 and I'll start pushing data into that, the transaction data into that to a specific limit, which has every block has a defined limit which of data which it can store. So usually in Bitcoin blockchains or any other blockchains, I mean, it can vary from 1 MB to defined, it can be 10 MB, it can be 50 MB, it can be anything what we define it to be. So that's the capacity of a block. Once that capacity fills up, it starts to go with the next block. Now, let's say the concept of a genesis block is that it is the starting block, 0th block, which needs to be defined manually, because nobody has come up with that address yet. The next addresses of the block come up automatically. As it processes data, it will come up with the next address block. So this chain continues and continues till the current block. So you can see block 2 will have a backlink to block 1, which is the block 1 hash. Block 1 will have a block 0 hash, but there's no back hash for block 0. Hash is nothing but a linkage, like address of what is the address of block 1 and block 2. What are the data stored in between? We'll go with the next slide and see what. Before that, let's move to the next slide and understand why this systems came into being. So this is the clip of a historic newspaper article which led to the birth of blockchains and bitcoins. Bitcoin was the first blockchain implemented. So this is why it came into account. So the frequent bailout for banks being the central entity, as we have understood in the centralized systems, they were defaulting every single time, and the bailouts were being done. And who pays for the bailouts? The people of that country. It could be India, it could be any other country as well. So this was a problem, and the person Satoshi Nakamoto said that, okay, no, we should not allow this. Instead, we should have a solution which eliminates the middleman bank who are controlling the entire flow of the transactions. We enable a direct peer-to-peer transaction. We make it transparent so that anybody can check whether the transaction has happened or not. And the first and the most important part is making the transaction immutable so that they cannot be changed by any third party. So this is what is enabled by the solution which is proposed in the next slide. So let's go to the next slide. So when we create a transaction, so how in the last slide we understood that this particular concept is enabled by using blockchains. How do we exactly do it? So let's see a real life example. Ma'am, there is a link on the right hand side. Can you click and open it? It will lead to a control click will open it, and it will lead to a page. It's a real time page which will show us the exact data, and there are certain more fields which I want to explain why we can use this concept as a solution for our healthcare system.
Yeah. Namit, I'm unable to
control and click that.
Control and click. Okay.
No, or you can copy that link and paste it in your browser, ma'am.
It will not work, Shalini. Control will not, because it's a PDF file. You need to Control C, copy that URL, and then paste it on the net. Yeah, I don't know whether.
No, then she has to open the.
Press escape, and then you have to do it in the original file. Yeah.
Okay, I'll just stop sharing for a moment.
I can take questions in the meanwhile if anybody has questions.
Namit, it's open.
Okay. Yeah. Thank you, ma'am. Yeah, so if you scroll down, ma'am, we need to go to the option which says message. There's a field which is called message. Yeah.
Are you able to see now?
Yeah. Can you still scroll down a bit below a bit fully so that we also have inputs and outputs? Yeah. So when a transaction on a blockchain happens, this is specifically for a Bitcoin blockchain, we are seeing just one example as to how we can utilize this concept to arrive to store data for our medical health records. So if you see, the starting address is, there's an input address and there's an output address. So this particular address is sending amounts to the other address, which is 0.0018 Bitcoins. The idea behind that is it's not a, we can translate the idea of a Bitcoin to information. What it means is, first person, the input person, is basically asking for some kind of action with the other person. So it translates into a consent basically, or it can be data also. So along when I initiate a transaction, there's an input, there's an output, along with there's a metadata along which is at the header. Can you scroll up, ma'am, a bit above? I wanted to show you how a wallet also looks, but it's on my machine, but I cannot show it. So maybe I'll just use a different way to demonstrate that. Yeah, ma'am. So if you can slightly scroll to the message part, that this is the transaction ID. What is the transaction reference is given at the top? That is the identifier for that transaction. So any action can be translated as a transaction, and a transaction will have an identification number, which is given above. Now, if you see the message part, it says any, along with the transaction, you can have a comment or you can have a data storage. So for this particular message, it says, all the best, Geo, I wish you another 40. So it implies that we can store data in that particular field, and that field will enable us to, that is permanently stored in the blockchain. So I can also retrieve that data. The other option I have is to encrypt the data first and then store it. It means that I can store any kind of data in the blockchain. It can be, if my blockchain is my custom defined blockchain, it's not a Bitcoin blockchain, that data can be of any length. There's no restriction on the length. So I hope the concept of storage of data on the blockchain is clear. Let's move to the next slide and see how can we retrieve the data, and how can we utilize this concept to further our cause for e-health records. Ma'am, yeah. Ma'am, can you share this presentation?
Do you want me to go to the next page?
Yeah. Let's move to the next slide. Yeah. So in our normal blockchain, Bitcoin blockchain, what happens is there's just peer-to-peer transaction. That is, one person interacts with the other person. There are only two entities involved. But this does not help us in our hospital or e-health record systems, but because in practical scenarios, we have multiple entities. Can we just move to the last slide, ma'am, please? You must have seen that in the video. Last slide, yes.
Last slide, you think? Okay.
Slide number 13, ma'am.
Okay. I'll have to go page by page. Sorry.
This is the last
one?
Yeah. So in our regular e-health, health care system, these are the entities which are involved. So how do we add all these entities and enable their choices or their consent or their involvement in the entire process? How do we simulate that flow in using blockchain? So let's go back to the original slide, ma'am. The previous slide, what we came from.
Sure.
So the concept started with Bitcoin blockchain, but it is available for any kind of blockchains as well. What it enables us to do is, it enables us to have multiple entities transacting with a single transaction. So let's say if there is a group of people who want to enable a transaction, only if let's say two of the people agree to that, and two or more more people agree to that. This is the same example you're seeing on the screen. There's a person, Justin, there's a Witty, and Craig. These are three people who would like to have control over a transaction and enable the transaction only if two of the people will allow that. If they allow that and sign the transaction will go ahead. And it can be either Witty and Craig as well, or it could be Justin and Craig as well. It simply implies multiple people can have their consent or agreement for a specific transaction, and that only then the transaction moves ahead. If any of the condition is not fulfilled, the transaction will not go ahead. This is specifically in case of Bitcoins, but the same concept we can translate to our e-health record, saying that if multiple entities are involved, and let's say the doctor is saying that, okay, let's not go for this, maybe it could be orthopedic person, there could be someone from the anesthesia side and saying that, okay, no, this could be dangerous, so we should not allow this, so this consent is not required. What this enables is every entity's information input is stored in the blockchain, and that can be verified, like who actually disallowed the transaction, where did the blockage came up, and this is public. This information can be accessed by anybody who has a relevant access to the to the system, and this is not limited to one single hospital. Let's just remind us that what we are trying to solve is to solve the silo problem of the hospitals, where the data resides within the hospital premises. But imagine a scenario where PII of the patients is removed, and the hospitals are able to clearly exchange data to figure out, okay, this could be this could be a treatment modality also. We could go for this kind of a treatment which this hospital has recommended. Alternatively, there are so many use cases of sharing data, which will come again in the last slide. For now, let's just understand that how the multi-signature transactions help us enable the solution we want to come at. So consent of each individual is required. Consent of every entity is recorded. Only then this is enabled. I hope this is clear. Let's move to the next slide. So this is I wanted at this point I wanted to show what a single wallet looks like. A blockchain is made up of blockchain. As then how do we access the content of the blockchain? It is through wallets. Ma'am, if I can request you to go to the browser and just search for blockchain explorers, Bitcoin explorers. Just type a real-time query in the browser, Bitcoin explorers. And there we will be able to see that all these transactions are part of the blockchain, and there are different ways to read that information from the blockchain. We usually have a client.
Tell me, I'm sorry, tell me again.
Ma'am, Blockchain Explorer.
And
yeah, I mean, you can share your screen. I will let you know which links to go over.
Sure. Is this what you were looking for?
Yes. Can you just scroll a bit down?
Sure.
You will see a list of transactions happening. You can see let's just scroll down a bit. We need to see the list of transactions. Yeah, latest transactions. See, I'll just give an example. No, ma'am, we need to go back.
Sorry, okay. Just a moment. Here, right? You want me to be here, right?
Yes, ma'am. Thank you. The latest blocks is the list of the blocks, and every 10 to 12 minutes, the next blocks are figured out specifically for this particular blockchain. So what happens is we will see as soon as the transactions are identified, they're pushed into the blockchain, and these information is there. Can we go back to our previous presentation, ma'am? The presentation.
Sure.
Ma'am, you can share your desktop, then the switching can happen immediately.
Here we go.
Yeah, thank you. So that's one way of accessing the information. But if I own some bitcoins, or if I own some some transactions, how do I actually control them? That is through concept of wallets. These wallets are basically client machines, like client as in the software clients, which connect to the server. The server in this case is peer-to-peer connections, and basically it's not exactly a centralized server. We basically connect to the other peer, and that peer will enable us to see whatever the other transactions are happening. It will share with us. So this is a sample of a multi-signature wallet, which enables us to have a concept of multiple people controlling a single transaction. You can see as in there's a joint wallet controlled by 3 owners. You can see, I hope you can read the text on it. So whoever the wallet owner is, that identification is there with the wallet. It's not a static identification. It changes. The identification changes as well, depending on the implementation. Also, it can be static, it can be dynamic as well. It can be either of the case. So the ultimate idea is to understand that there can be multiple entities controlling a single transaction, and each of them have their own control over it. So let's move to the next. Before that, I will just point out to the link here. For if somebody wants to browse through the code of the wallet, how it looks like, the link is given. I'll share this presentation afterwards on Telegram, so you can have the link later on. The next concept we want to come up with is a concept of virtual IDs. A virtual ID is nothing but you can say that it's an alias for an existing ID identification. Let's say somebody's name is Namit and the alias can be NK. So it's just like it's a pointer to the actual to the correct record. In this case, our government has enabled a very wonderful concept of virtual IDs in Aadhaar. I'm giving this example because this is what is proposed in the solution as well. What it enables us to do is to mask the actual content of the Aadhaar number, which is the primary identifier. And as we have seen in the earlier PII data, thus identifications are also part of the PII information. We cannot share the personal identification numbers of the person. So what do we do instead is we create an alias number and just simply point it to the original number, saying that, okay, instead of using the original number, we'll simply have an alias. So there's a problem with this. What if people start recording the aliases? So the good part is you can change your virtual IDs at a specific period. So that flexibility is also given out. We will be utilizing this concept itself to come up with a solution for enabling virtual identifications with each request we go ahead with the transactions. So what this enables us is come up with a number which is linking to the original number, but also that number also changes. So somebody, if there is let's say there's somebody who's recording all these numbers and he wants to store the data, that person will have to do a lot of effort to come up with the latest numbers, latest value of the current person's alias. So what if it happens with each request? So let's say my Aadhaar ID is XYZ, whatever is, let's say it's given. So with every request I put up in the system, that number changes. So there's no way, anybody can have my original numbers. So that is the strength of utilizing a virtual ID in this place. So let's move to the next slide. I hope this concept is also clear.
Namit, I wanted to ask here, like
Sure.
I've never used this feature. Is it like an OTP that you request for this gets generated, you use it, and next time again you log in, you request for it, you get it?
Ma'am, no, ma'am, it's a different concept. You know the concept of alias, right? A person cannot have multiple names. Like let's say the person's name is Namit and the alias could be NK. So if somebody says NK, it will still refer to me, right?
Right.
So
But Sorry, Namit, this is Reena. In the case of alias, how do you identify a unique alias for a given name? Because one name can be multiple people, right? I mean, in the sense, same name can have multiple people referred.
Ma'am, it's the alias is generated based on the Aadhaar number. It's not based. It's not generated based on the name.
Oh, okay.
So it's a unique ID. So every alias, let's say I have generated this 91406597. This number is generated based on the original Aadhaar, which is 1120. So another ID can be generated, like current ID is VID is 9140. Let's say I want to change that. I can also change it again by doing a OTP process, and then a new ID will be generated. A new VID will be generated. Is it clear?
Okay, okay. So it's a random generated number.
Yeah, you can see that. No, there's an algorithm. It's not randomly generated. There's an algorithm behind it. And that algorithm is generating these numbers.
Okay.
But those numbers can be regenerated as well. The previous ID will be invalidated.
Okay.
So is it like that my Aadhaar card number stays protected and I
Yes.
keep on using the alias number that I've generated?
Yes, exactly. Yes, that's why this feature has been introduced.
All right.
So
Okay.
what happens
Thank
is,
you.
because Aadhaar is used in many government related transactions like property or birth certificate, like death certificates, or there are so many use cases, marriage. So just to prevent the abuse of the Aadhaar card, people, the government initialized this concept of VIDs. We'll be using the same
One
concept.
question.
Yeah, ma'am.
Like suppose I use this particular VID for a transaction with government. So this particular VID gets recorded in their record, is it?
Yes, that instead of original Aadhaar number, this identification will be recorded there.
Okay. So in future, if I change my VID,
yes,
and somebody has to again recheck if it is the
yes.
Person we are referring to, how does it work? Like
internally,
at that moment it gets validated, so they depend
no,
on that?
no, it is invalidated immediately once you start a new ID. So in case you have submitted somewhere, if you have submitted your Aadhaar somewhere, there will be a need to resubmit the Aadhaar. This let's say they want to recheck it, or let's say it's a bank and they want to do a re-KYC every 2 years. So how do they go ahead with that? So you have submitted the previous VID. Now they are trying to access and validate the Aadhaar card. The VID will be invalidated, but they will say, okay, you need to provide us with your current VID. You don't have to provide the Aadhaar data. You can provide them the new VID.
Sure. So in case I, as an individual who has submitted this number, feel that, it has been breached, I can change it, and then authorities can reach out to me and seek another, is it?
Yeah, normally it's from your side to the authorities. In usual cases, I am yet to come across a case where they demand a new VID, but normally they will ask for to submit the latest KYC documents, and that includes the Aadhaar number. This Aadhaar VID.
Thank you, Namit.
Okay, so this is the concept of virtual IDs. We will move on to the next slide. So what happens? How is the current medical information medical systems structured? If you see the last slide, it says, let's say I want to go for an X-ray, so it will have my information written out there, right? Like what is shown here. On the right hand side is another example as to how the information is stored in medical systems. Let's say if I go for a dental X-ray, or if I go for a normal X-ray, I will have all my information, personal information, also embedded with that record. That creates a problem because this data cannot be shared with other hospitals, as we have seen in the earlier and the draft proposal that we should not disallow the sharing of data between hospitals. So how do we go ahead and share data like that? So the solution is, as you must have seen in the video, solution video, the idea is to separate out the personal PII and the basically the medical information. As you can see, the medical information has basically the image of the X-ray. And on the right hand side, it could be based on the software. There, there is DICOM software. There are other CT handling softwares. All of that data can be managed. The medical data can be separated, and the PII data can be separated. So in this example, let's say on the left hand side, the patient's name is John Williams. Name comes under the PII information. So let's say we want to have a conforming system, conforming medical record, which we can share. What we can do is we can generate a request from John Williams, initiated by John Williams, saying that, okay, this is my ID. And that ID can be replaced by the patient name. So instead of John Williams, if a number goes 1190937, to another hospital, the other hospital cannot determine who is the patient. But the useful information is the patient's medical data can be shared with the other hospital. So that is the advantage of anonymizing. This is basically the concept of anonymizing, and that is what the concept says. So let's go to the next slide. Yeah, so let's come up to the various use cases this particular system can have. So there are different entities here. Patient, healthcare professionals are there, the hospital, basically the hospitals, and or it could be independent doctors also. All kind of treatment modalities can be included here, not just allopathic. The pharmaceutical companies are also entities here who are producing medicines, also need research and also need various testing of medicines as well here. Ancillary professionals include reporting and testing facilities, which are basically, like X-ray, CT scan, blood report. All of that comes under the ancillary professional. They also need information to the patient, or they also need to provide information to the patient. The insurance companies are also a vector here, are also part of the process here, because they will provide the funding, or if it is a TPA, or if it could be a different kind of insurance funding. So these are different modes of supplying access to the system. NGOs are the most important part of the process here, because they are the ones who initiate various campaigns, who initiate, let's say there's an accident, the person is unidentifiable. How do we go ahead with the processing of data in such a case in this system? We need the help of NGOs who can responsibly take care of the person, or till the time the person's identity is revealed. And it could be also public researchers or activists who want to, let's say there was a case of of a specific private hospital which charged like 17 lakhs for treatment of dengue in I believe in North India. So such cases can be pointed out, okay, that the approximate cost of the treatment is not like that what is being suggested by the hospital. It could be like somewhere in between, or some values, or it could be a less value. It basically creates a standard for different things, like it could be cost, it could be medicines, it could be treatment modality. There's so many use cases available here. Let me discuss the case of pharmaceutical companies, which is very interesting one. Because let's say there's a case of corona and we do not have a solution for how do we treat the case. In this case, the best solution is let the pharmaceutical company come up. They obviously have to get it tested, so the testing happens in trials, in phases. So the trial phases can be distributed to different patients, and their consent can be taken, saying that we can bear out your treatment expenses, but we would like some volunteers for this kind of our trials, or something like that. So this is a good use case which is beneficial for both the patient as well as the pharmaceutical companies. If you must have seen the concept of hybrid, the centralized data storage. So once we remove PII from the medical information, the entire information can be stored in a centralized system. I have also explained in the video why it is a bad idea to store all that information in the blockchain, because it's just overwhelming on the blockchain data centers. We don't want to store so much redundant data. It's just a waste of efforts and energy. So better is to store it in a centralized system, which can be accessed by any hospital, any person, any of the entity who is there. So even a law enforcement agency can see the disease data. So that creates that access, consent-based access, gives us a system which is completely transparent, which is part of the solution. If you recall in the second slide, which was part of the solution of having it transparent. That's the data here is immutable also. So once the data is entered into the system, nobody can change it without going unnoticed. So this gives us a very good system which enables complete transparency, complete data flow, privacy is maintained, consent-based mechanisms are there for each action. Let's say the patient wants to access wants to go for a wants to go for an appointment. What he will do is he simply creates an account using on the blockchain, on the personal data identity blockchain. That blockchain, once the data is there, he can initiate a virtual ID request. That request, his personal information will not be there. That virtual ID which changes with each request will be sent to the hospital, whether they have an appointment slot or not. Once they agree to that, that consent is also recorded. Once that consent is recorded, the patient goes to the hospital, visits it, then the diagnosis stage comes in. In the diagnosis stage, the hospital doctors update it in the disease data report, which again has its virtual ID. Instead of having the patient's personal PII details, a virtual ID is created, and that data is pushed into the central database. That data is accessible by any hospitals throughout the country, and that data can be replicated at different data centers to maintain availability and to reduce latency of access. Once that information is pushed, let's say there is a requirement for having medical reports, blood, or it could be CT, or it could be X-ray, or some kind of a reporting is required. So that reporting ancillary professionals, that request is sent to the ancillary professionals. They accept it, and the patient visits them. And once the patient's reports are there, they push it back to the disease report data, and that access is again available to every entity available in the system based on the consent of the patient, and in sometimes the hospital. So let's the hospital wants to enable access to the insurance company, so they will enable the insurance, the patient, with the consent of the patient also. So all of that use cases are possible in this kind of a system. So this enables us to come up with a complete thorough system which will help all of us in terms of streamlining and making efficient our treatment protocols, our treatment lines. We can have differential diagnosis. Let's say if the disease is not getting diagnosed, we can see in the database like such a disease was there or not with other people in other states. It could be a region based disease. Let's say a specific region is infected with specific strains of disease or virus, so that can be addressed as well here in this case. It can be compared with other areas. Expanding this system to other countries can create a worldwide database, but I mean that's beyond the scope of our act, PII, the Disha proposed act. So overall, what we have is a wonderful system. It is not a workaround, it is a complete solution, and the idea is open. I would invite anybody who would like to execute this, please go ahead. This requires a lot of effort, this requires a lot of resources. So enabling this or making an individual making this is kind of it's kind of an overhead for that particular developer or a company. So if large companies take this over, or they work together, this system can be enabled in India, and this will reduce a lot of overpricing, lot of treatment medical legal cases. Everything gets cleared out. I hope the presentation was good. Please, if you have any questions, please go ahead.
Namit, Anand here.
Yes, sir.
What is the scope for the traceability and auditing in this? Because blockchain, my superficial understanding, it is highly secure and kind of thing. So does it have the easy provisions? Sir,
an audit, let's say an auditing entity can be created here in the system, which has access. So everything is key based here. So when a transaction happens, every person is assigned a private key. So an auditor can also have a private key, and that the privileges can be controlled by the key. So yes, it's easily possible to do an audit. The person will have can have a differential access or the entire access based on the access rights of the key.
So in the case of MLCs also, the investigations or the inquiries being done, the same approach can be taken, right?
Yes, I mean it's just a key, right? If it is issued, because everybody in the system needs to go with the process of issuing the key, right?
Okay.
So I wanted to show that system. I mean, unfortunately, I cannot share the screen. So I mean, it would have made the concept clear.
Okay. Thanks, Namit. Yeah.
Namit, could you go through the chat and attend? There
Yeah,
are
please.
a few questions there.
Sorry, I actually missed the chat. 1 second, ma'am, please. Reena ma'am, I hope the blockchain concepts were clear. I covered them thoroughly. I hope they were enough to clear the concepts.
Yeah, thank you. One related question. So, whatever you have covered now in terms of the medical industry practice,
Yes,
is
ma'am.
this being adopted in India, or is
No,
this
ma'am.
like
No, ma'am. The draft is, there's no authority as such. The
Hmm.
nearest there's a APSHA report, which is the most followed one. People have their own inbuilt standards. So what they are doing is just trying to create silos. Hospitals are not sharing data with each other. Even if they're sharing, it's not in public. If it's not a public sharing, they have the internal processes, as I explained earlier. They have specific processes to share the data internally.
But the government doesn't have any.
There's no. This is why this draft was proposed. But I mean, there's no action on this draft so far.
Okay, thanks.
In Aadhaar example, what this is a question from Reena ma'am.
That we talked, right? I mean,
Okay,
I wanted to understand how that alias is created, and you said that it's
Yeah.
a algorithm, which
Yes,
is
ma'am.
yeah, okay.
So there will be an algorithm which generate. Anand sir says, and student, yeah. Dr. Lemus says, as suggested, if the hospital data is open for multiple hospitals through the concept, won't there be difference of opinion regarding the treatment proposed and operation suggested by? Yes, sir. There's quite possible, and it's actually a good practice to have different opinions about it. Whatever opinion is the most followed one is the one which will come up at the ultimately. So it's just like having different options, and which option is the best way is the better way to go ahead will come up as the solution.
One other question. So this Hippa, which is there in US,
Yes, ma'am.
that uses this whatever concept and the process you explained, or how is it?
In Hippa, there are definitive fields. Even in our e-health records, which was 2013 and 2016, we have an e-health EHR guidelines. It's not an act again, but those have specific data fields. The names are defined. Their connectivity is defined. What is available for sharing, what is not available for sharing. That is also. What I will do is I will share all those entire details in Telegram after this session ends. It's very interesting. One must go through this. I mean, it's huge. I mean, I'm just being brief here for lack of time. So just I will share those documents.
But these large hospitals like Apollo, AIMS, and all, they don't have any work going in this direction. I mean,
I'm not in touch with them, but I'm sure they should be working. As far as my understanding concerned, what happens is mostly, specific in this region, there's a person from Nagpur who is supplying all these softwares which are managing different hospitals infrastructure. So what happens is individuals provide solutions and they have limitations in their solution. They might not even know about the privacy issues, because these are you can say lately introduced, but those solutions have been in use since the past. So quite some time there could be a difference.
Because it's a huge opportunity actually, if you see.
Ma'am, that's why I wanted somebody to take this up. I wanted to do this, but this just too much. It's too much work. I mean, it requires a huge team.
Yeah, we need a mini FDPPI like organization.
Yeah. So Anand sir says, like your Telegram user ID. Yeah. Something I believe he's suggesting the solution here.
Sir, can you hear me?
Yes, sir.
Anand here. So my question is in the slide which is being displayed.
Yes,
So
sir.
patient comes and patients interacts with some software which actually is an interface to blockchain. All that is okay. So assumption is patient is okay, means patient wants to schedule an appointment. What happens in the case where patient is unconscious and he doesn't have his ID? What
Yes,
is
sir.
this?
Sir, I talked about the concept of NGOs here. There's an entity called NGO. So if the patient is not at all there, if usually every hospital has a social worker. I mean, there will be somebody there who takes care of such cases. Even if any report is required, that as I said, the blockchain data is immutable. So there will be certain initial filling of the data by the NGOs, like a random data, but later on, once the patient's identity is finalized, that data will be over, that a new record will be created and the earlier record will be invalidated. So the patient's latest record will be taken into account. So that way the person can be identified and the further treatment modality can go ahead. In this, to answer your question, the NGOs are the key here.
So every hospital should have that interface, like an NGO person to.
Yes, it's a good idea. It's a good idea to involve social people, and that also eliminates the misuse. Sometimes the hospital, let's say it's a scrupulous hospital, and the hospital is shady, and the body parts can be taken out. What happens then? The person is unidentified. So in such cases, a public channel is suggested, which is the NGOs, and they can go ahead with this.
Fine, sir.
Namit, I wanted to add one point here. Like in data protection laws also, they mention in case of emergency situation, there is consent is not needed.
Yes.
So like the hospital can go ahead and,
Yes.
initiate and
True.
generate an ID and later on can overwrite it, right? Why would we seek a
Because
public agency or like NGOs to come into the picture?
it is required because they represent the public. What in hospital is a closed entity, is a private end. Let's say it's a private hospital, or it could be a government hospital also, but it's a closed entity. The hospital taking, anybody treating and anybody taking consent is not a good idea, right? Without, let's say, the patient requires immediate heart surgery, but the NGO says no, an angiography is sufficient. What happens then? The hospital just wants to increase the billing. So to have a control on all the factors, every actor, every entity in the system has its own job defined, and that will control the other persons.
No, from the point of view of generating the initial ID, I'm saying, like, why would they wait to get in touch with the
No, the NGOs
NGO?
actually
Like,
are
go ahead
in-house.
with-
The NGOs are in hospital residents. Like they have a specific section in the hospitals.
That's this idea has origin in some, other like companies or countries using it.
I doubt, ma'am, but this is a complete solution which I thought of. I am not aware of any such practice which is happening even in USA. The US process is very simple. They have the way normal the work is, simply the idea is try to figure out. But if it is not there, they also have they have a third party hospital manager. I would call it a manager, but it's kind of it's kind of an interface between different boards, the controlling board and the hospital. So they take the decisions in that case.
No, but I was just saying that as far as data protection is concerned,
Yes,
consent is not required in this case. First thing. Second thing, like for what do I call it? It can come under a review of whether the hospital is practicing fairly. So,
So ma'am, in this case,
I don't know, a government authority would hold that authority to, question than NGO or public researchers. I just wanted to,
it's not a holding part, or it's not a suggestion from their side. You're saying that you're suggesting that the healthcare professionals, the hospitals can take the decisions themselves. That is what I wanted to address. The hospital's consent is fine, I mean, they can take an action, fine, but who is there to control them? Right? So the process involves such involvement of such entities. The way it is defined is that way, to control misuse, control abuse of power.
For
I
that,
hope,
the law exists, right?
ma'am, it's the
I mean,
law.
if-
Enforcement is different. Law is different.
Yeah,
Enforcement
so
is different.
so you gave me the right word that, for that enforcement agencies are there, right? So
But the
in case
process,
the
so instead
enforcement
of depending,
agencies bring in,
so yeah, so instead of depending on a specific agency, why not follow a process?
like, if these NGOs or public researchers could be on their panel of
Yes, normally it is the case.
enforcement agencies, then it can be introduced. Otherwise,
Yes, those are
uh,
normally
is
the
there-
NGOs.
is there any- Okay.
Yes, ma'am.
Okay.
Please go ahead.
Got it. Namit. Thank you.
Okay, ma'am. Harish sir, sorry,
So
Anand sir.
to give an example, ma'am, what was that previous thing which we had in Karnataka regarding the health insurance? In every hospital there will be one person. So if they go to a private hospital, there will be one person who actually manages this insurance part to them. I'm not getting the name. It starts with A. So where they used to get good insurance, government insurance before the latest one by central government. So there will be one person who used to manage. So they used to go there and he used to manage the insurance thing. But ma'am's question, what might happen is hospital will not wait for that NGO person. They will generate it and then coordinate with that NGO person.
Sorry, I mentioned this. The NGOs are not, they don't have a different office. They don't have, they are in-house within the hospital.
Yes, yes.
So
means if it's an emergency case, so they will just do what they want to do.
Exactly. No. If it is an emergency case, it will still go through the NGO. The person is part of the hospital process, no?
Okay.
Yes, sir. So I hope
that was a good example, Anand. Thank you. That
Yes.
clarifies the point, Namit. Thank you.
Thank you, ma'am. Harish sir, what is the authentication mechanism? Somebody wants to edit the record, upload the report of a person. So authentication mechanism is the key. So every entity is assigned a key, and if the key has that authority to access the relevant record, they will be able to add a new record. The old record will be invalidated.
As I understand, this blockchain, any modification of an entry of a record, it has to be like authenticated by the peers. So how this is done here?
Sir, it is a new transaction. It is never edited. The word I use is immutable. The blockchain is immutable. It means that it cannot be changed. So to have an edited record, the idea is to add a new record and invalidate the old record. Does this make sense?
Okay, so no need somebody to authenticate, like authorize this transaction, modification or deletion or update.
Sir, the access rights of the keys will define that. If the person who is the entity has that access to the record, let's say it does not require a patient's consent, it just requires the hospital's consent, so it will enable that. If he has a key, if his client has that access, he will be able to edit it. I mean, by editing, I mean he will be able to add a new record and invalidate the old.
See, that is in the normal database scenario, but in the blockchain scenario, the peers has to
no, sir. This is
no,
okay. Sir. That is the creation of a new record.
Okay. So here also, a patient walks into a new hospital and he'll get say X-ray done. Then that is a new record.
It's a new record, and the previous record, if needs to be edited, it will be cancelled in the blockchain.
Okay.
So the point, basically, it's the pointer. So as I reference, if you recall that slide, every transaction has a transaction ID. You recall that slide?
Okay.
So instead of pointing to the previous transaction ID, it will point to the recent transaction ID, the latest one.
Oh, okay.
Okay. So let's, what Andaram sir says, I think doctors and hospitals may not agree for this experiment. Okay, the doctors may have no time to conduct surgery as they have to be on the system rather than on care of the patients. So yes, this is, doctors definitely do not have that role. So the hospital manages the, the paperwork and all. They can define the process as I defined. It should have actually answered your question, because there are people within the hospitals. The process has to be followed. Otherwise, there are chances of abuse of the system. I hope this answers your question. Can you comment on the HW requirements to set up hardware requirements to set up the blockchain? Sir, I wanted to show it's. I mean, I wanted to show a blockchain, but unfortunately cannot show it on my system. But to give you a size of the size of the blockchain, Bitcoin blockchain sizes are approximately 380 or 350 or something GB. Litecoin blockchain are around 50 GB. So that's the size of the transaction. Hardware requirements, you don't need a lot of processing power for this. So as a lower CPU is sufficient to handle the load, but you need a lot of memory space, and you need a faster parallel processing power. So you require, you might require graphics cards for parallel processing, or additional hardware ASICs, which are called ASICs. Basically, these are used for mining, but they can also, basic for using the basic blockchain. These a basic system is sufficient. But if you want to go advanced, you will require advanced hardware for that, which is expensive, which is quite expensive as well. Reena ma'am, very inspired. Thank you, ma'am. Thank you so much.
Sir, one question, because I used to work in healthcare IT domain previously.
Yes, sir.
The issue we used to face is, means we still face, is like the interoperability of the software. So once, like what you mentioned is the linking of hospitals, means what happens is, say, for example, Apollo uses one software and Manipal uses one software.
Yes, sir.
So means if the government says that this is the blockchain you have to use, then they will figure it out. But if it's a voluntary thing, so then they have this problem, like which the data will go to the blockchain, but when it comes back, if the software which they have is not compatible with it, then ultimately they will not actually say yes to this.
So there's a simple solution. There's not a problem. It's not at all a problem. Number one, the reference system is supposed to be this, what we are proposing. So hello. So the reference system is supposed to be this. So we can utilize this system as the base reference system. The existing systems can have a connector defined, which is basically API calls, and there can be middleware defined, which can be easily written. It's just a mapping of the software fields.
Someone has to mute actually.
Hello.
Yes,
sir. I hope I could answer the question.
Yes. So means in your solution, have you defined that API size, so that if they want, or it's up to the implementer to?
It's normally the private implementers of the hospitals. They normally have software integrators or software implementers also, who they go ahead and have contracts. So they can actually have it's a simple API mapping, not very difficult for any software implementer not to be able to do that. It's a simple solution.
Thank you. These solutions, one, it will help common people. There will be less barrier to entry, and it's a great means brings about a great level playing field actually to everyone. And as ma'am suggested, it was a very interesting session, and a lot of new innovative solutions. Hope someone implements this, and your dreams will come true. Thank you, sir.
I hope so, sir. Thank you so much. Kodandaram, sir, thank you so much.
Thank you, Namit.
Thank you. Thank you, everyone.
Thanks, Namit. It was a good session.
Thank you, sir.
Thank you, Namit.